Hi students and family members, this is Mr. Panza. We're getting you set for the district weather, water cycle, and space test today. We're trying to see what you remember about the water cycle, weather, and the solar system. In order to help prepare you for what can be a pretty difficult test, I've tried to simplify. I've given you study guides, and now I'm going to pinpoint just a few questions that you need to know from each study guide that you can study from. So, here we go. If at any point you seem to fall behind, just pause this video, copy down what you need to copy, and then you can use it for future reference. First, we're going to start with the water cycle. Remember, not all of these are going to be on the district test. The ones that I have placed a little star or an asterisk next to are the ones that you need to then write down and make sure that you study for the district test. So the first three we'll look at are numbers 2, 3, and 4. You need to know that energy from the sun is what is the driving force behind the water cycle. It's because the sun causes the water cycle to continually occur every single day. Precipitation is the form of water vapor that cools. When it cools, it will eventually turn to precipitation that will fall to the ground. And number 4, when rain reaches the ground, it can go in 2 different places that we learned about. It can become groundwater when it soaks into the ground, or it can run off into streams, rivers, and lakes. Remember, these questions will show up on the district test. You can skip the other parts and go down to the next asterisk, which asks, what happens to the water during the process of evaporation? You have to remember that when water is heated up based on the sun, it changes into a gas that we call water vapor. There was a lab that we had done during the water cycle unit in which I showed the students a boiling pot of water and expressed that this was an example of evaporation. The definition is the water changing into a gas. The example is that boiling pot of water. Another example is on a day that you maybe go out and take a dip in the pool and dry off with a towel. That wet towel will eventually dry off due to the process of evaporation. They want you to do the same exact thing for condensation. Can you remember that condensation is when gas, or water vapor, rises into the air, begins to cool off, and turns back into a liquid? Examples again from the lab was when I gave the students a bottle that was frozen to look at that had condensation droplets on the bottle. That's because gas is all around us, and the bottle was never opened, and even though the ice maybe was melting, it had nothing to do with the water inside the bottle, but the gas on the outside that was cooling and then becoming a water. The droplets on the water bottle are an example of condensation. So are the droplets that you may see on an air conditioning unit. As we continue, you can skip these parts. You can see the observation was a part that you can skip as well. And go down to the factor that you think determines precipitation. It's all about air temperature. Air temperature is that main factor, the thing that you need to remember that is the controlling force between what type of precipitation, rain, sleet, snow, hail, that we will receive. 32 degrees Fahrenheit is that magic number. If it's 32 degrees or above, typically we see rain, and if it's below, it's forms of ice. The top question on severe storms are going to be on tornadoes or hurricanes. A tornado is a fast spinning spiral of wind, and a hurricane results from a tropical storm. I know that I gave a lot of information on this line, but really all you have to know for the district test is that the result of a tropical storm that forms over sea, getting larger, is a hurricane, and that a tornado is a spiral of wind that is fast spinning. As we continue, we also learned about sea breezes and land breezes, but specifically we talked about that Florida was susceptible to many strong sea breezes, and that's because Florida is a peninsula. A peninsula is a body of land that is surrounded by 3 pieces of water. Florida has the Atlantic Ocean as well as the Gulf of Mexico. And because it's surrounded by those 3 bodies of water, it's susceptible to sea breezes that can hit Florida in many different directions, much like an island is susceptible to sea breezes because they are completely surrounded by water. So based on the fact that Florida is a peninsula is why sea breeze storms can occur there. When we talk about air masses, which are large bodies of air that have similar temperature and moisture, we need to know that those air masses moving are what cause change in weather. Meteorologists and weathermen will look at different air masses that are coming from different directions, and they realize that's what's causing the weather to change. The movement of an air mass is the causing of the change. We have warm air masses and cold air masses, and when they meet at a front, because cold air masses will always be on the bottom, but when they collide and then go under the warm air mass, the cold front, and when the warm air mass is moving over the cold air mass, we have a warm front. When we have a warm front, the likely weather to occur is steady rain followed by clear and warm weather. Remember, there's a lot of information here, but all you have to pull out is the front definition and the fact that the warm front will bring steady rain followed by clear and warm weather for the district test. That's because they have the asterisks here for you to study. Next, this is how weather information is collected. We talked a lot about the NWS, the National Weather Service, but specifically, weather information is collected at many different weather stations in every different state. These stations then report the information using weather tools to meteorologists. Those meteorologists who work for the NWS create weather maps that are then broadcast out. That's how information about weather is collected for and by meteorologists. And how do they measure that weather? With many different tools. There are 4 tools named here, although there are many different tools that meteorologists can use. The 2 that the book pointed out, anemometer and barometer. 1, anemometer, measures wind speed, and the barometer measures air pressure. A couple of others, rain gauge and thermometer. Rain gauge tells you how much rain has fallen, and the thermometer measures the temperature of the air. There's even more, but you only need to put 2 on your test, and I've listed 4 right here for you. Moving on to the planets and our solar system. The first thing I wanted to point out is the fact that the seasons change not because the Earth is getting closer or further from the sun, which is a common misconception, but because the tilt of the Earth on its imaginary axis as it revolves around the sun is either giving you direct sunlight or indirect sunlight. Direct sunlight would give you summertime, indirect would be winter weather. And a lot of people believe that the Earth moves closer and further as it's moving towards the sun, but it doesn't. It stays the exact same distance away. And because the Earth is in that perfect position, it allows us to have livable temperatures here on Earth. The moon, which revolves around the Earth, seems to have different phases. And the reason it does is because as the moon is traveling around the Earth, it is shined on by the sun or illuminated at different angles by the sun, showing different shapes. Here's an example of the shapes that we see right here. And if we need to place the phases of the moon in the correct order, it would be new moon, then mostly shade, then full moon, followed by mostly shade the opposite direction. Finally, I wanted to point out that the pattern of the moon phases repeat about once a month, a little over 29.5 days. As we continue to talk about our solar system, we also talked about how the inner planets and outer planets are separated by a belt or ring of asteroids. The inner planets are Mercury, Venus, Earth, and Mars. And the outer planets will be listed later. You don't necessarily have to list these planets, but you do have to remember which ones are the inner planets and which ones are the outer planets, and the fact that they're separated by the belt of asteroids. So these are the inner planets. Now, although the inner planets have lots of things in common, Earth is the most unusual of the inner planets. 2 reasons are because we have atmosphere in our oxygen, and we have liquid water. A third reason, although debated and studied, is that we have active volcano surfaces on the Earth. The 4 outer planets are Jupiter, Saturn, Uranus, and Neptune, and there used to be one further planet that was really small, which was declassified and then reclassified as a dwarf planet because it did not have a clear and consistent orbit around the star, or our star, the Sun, which was Pluto. So you have to remember that it once was a planet but no longer is, and that these are the 4 outer planets. Finally, at the bottom here, we're talking about the stars. A star is a huge ball of superheated gases. The Sun is a star at the center of our solar system. And when we look up into the sky, we see different colors. You just need to remember that the colors tell us how hot or how cool they are. You don't even need to remember that red is the coolest stars, blues are the hottest, and the sun is yellow because compared to the red and blue stars, it's somewhere in the middle temperature-wise. The final question that I wanted to point out was, from ordering smallest to largest, how we can see things in our solar system. The constellations we can see from where we're standing at night when we look up, they're the smallest compared to the galaxy and everything that exists in space, which is the universe. I hope this video helps you, as all of the starred questions will again be seen on the Science District test. Thanks, have a great night.